Welcome to the webAI summer release. The team has been working hard on some incredible new updates, and we can't wait to show you what we've been working on. Today, we're going to unveil powerful new advancements that change the way you approach AI. You'll likely have questions along the way. Scan this QR code to submit a question or simply ask us on X. As we head into the second half of the year, 2024 is proving to be the year every business is looking to implement AI and drive better productivity and profitability for their business. But this is uncovering a whole new set of challenges and threats to your business. We've all seen the news about privacy issues and AI. Business leaders are torn between trying to adopt AI, but also protect IP that they have spent years developing. Nobody wants their data to be used for training, or worse, sold to the competition. And new questions are rising up around who actually owns the models trained on your data. Is that you? Is that your provider? What if you leave a vendor? Can you take that model with you? This is not just about data privacy. Cost is a growing concern. Emerging AI models require a tremendous amount of compute, and AI vendors are pouring billions into development and maintenance of these AI solutions. Today, these inefficient models are subsidized by vendors, but over time, these compute costs will be passed along to customers. Most critical of all, out-of-the-box AI isn't able to address core business needs. For example, prompt engineering does not solve real business problems. It's not delivering on the promise of AI. At webAI, we believe in order to solve business problems with AI, we must first solve the problems of AI. It starts with privacy. Rather than bringing your data to the cloud for AI processing, we bring the AI to your local device, where the data is being generated. This can be from an existing camera or a simple chat on your laptop. The benefit of this is your data never leaves your systems. You stay in control of your data and the models you train with it. webAI runs on your existing hardware and network. Likely the device you're watching this on is powerful enough to run an AI system with webAI. Our technology allows you to power some of the world's largest models on consumer-grade hardware. And when one device isn't enough, we can link devices together to create powerful clusters that you control. Finally, webAI comes with everything you need to train and deploy models to meet your business requirements. We're still in the early days of AI, but we believe the future of AI is a future that's secure, energy efficient, and will take place directly on your device. To show you how it's done, please welcome Tyler Maurer.
Thanks, David. We've taken an innovative approach to solving the challenges of AI, and they all come together in Navigator. Navigator is an enterprise AI platform that allows you to run artificial intelligence models on your existing hardware. If you need to train new models for specialized solutions, our training pipelines allow you to quickly move solutions from prototyping to production within the same environment. Moving solutions from experimentation to production has never been easier. Our powerful backend combines state-of-the-art networking with a powerful runtime agent. Let's take a look at how it's done.
The first thing you'll notice is that this isn't your typical training and prototyping tool. It's so much more. In the bottom left, I have my elements. They're grouped into different categories. I have my inputs, my outputs, inference elements, and my training elements. My inputs, I'm able to keep track of my resources like my cameras, my prompt API, or my media loader. For outputs, I'm able to upload output previews, APIs, or zone counters. For inference elements, we're able to run large language models, object detection models, classifiers, and so much more. And one of my favorites is training, where I'm actually able to train custom models. That goes from everything from a large language model to vision models as well. So let's go ahead and train one. I'm going to drag in a LLM trainer and go to the settings. I'm going to take a data set I had from earlier based on automobiles. And then all I'm going to have to do is hit run, and it's going to start training directly on my device. And you can see here that we're actually installing the dependencies required and setting it up directly in your environment so you don't have to code at all. And this is going to run in the background. And while that's running, I trained one earlier today, so I'd like to go talk to it and see how it's performing. I'm going to load a custom LLM chatbot. And then I'm going to go into the settings and click on the model that we trained earlier. We're going to hit run, see how it performs, and if it does great, we'll push it into production. The cool thing about this is that all of these flows are created based on modularized pieces of code and they're orchestrated perfectly to work in the background. And when I want them running, all I have to do is click drag and drop to get them connected. And let's go ahead and test this model out. Give me a brief history on Ferrari. And you can see that this runs directly on my device. And as some great information on Ferrari, I think that my friends are actually really gonna like this model. So I'm gonna go ahead and push it to production. So let's save a version for deployment. Call it at Cars 1. I'm gonna switch to the deployment view. We're gonna name it. Keep our naming thing consistent, Cars 1. Select the version. Assign my hardware. And in this case, they're all gonna run on this computer. If I had other devices connected, I'd actually be able to run them on a cluster. But for now, we'll just keep it on all that time. We're gonna hit next and push it to deployment. And speaking about deployment, we have something fun to show you. Let's go take a look.
Navigator brings accessibility to AI, allowing anyone to solve robust and difficult problems. Our team has continued to innovate on the platform's foundation and have created a solution that allows you to run extremely large models in hardware-constrained environments, and we call it webFrame. webFrame allows you to deploy large and complex language models and host it across multiple devices in your network. It breaks down the models into small components that get distributed across separate machines. These machines work together to run state-of-the-art models directly in your environment. Here we have a cluster of 4 Mac studios working together to power Mixtral. 3 of these machines are running Navigator's worker mode, which allows the resources to be pooled and made available to the main device here. Similar to when you run it on a single device, I can create an API endpoint for integrating external applications. Let's talk with it. What are the 3 benefits of running distributed compute? You can see here that we have the model running on 4 different computers that we have clustered together. And it's going to perform exactly how I'd like it to. It's going to populate the results in my chat. Mixtral is an incredible model, and unfortunately I've never been able to use it offline because it is so large. webFrame breaks this pattern and allows me to access large models without going to the cloud. The best part is Mixtral performs extremely well, and it competes with popular providers like ChatGPT or Claude. Now I can get the results I've come to expect from cloud solutions without the risk of leaking personal or professional information. I'm going to leave this model running so my coworkers can chat with it from their laptops and mobile devices. There's one more example I'd love to show you. My laptop doesn't have enough compute to run a model like Llama 70B by itself. But with webFrame, I'm actually able to contribute my laptop's compute to the cluster. Navigator is currently running half of the model on my laptop while the other half is running on the ML cluster. This allows us to minimize the dedicated compute requirements for the Mac cluster while maximizing its ability to serve more users. webFrame works with the largest models available in the open source community, and we think you guys will enjoy using them.
By bringing the power of large models directly to your device with Navigator and webFrame, you'll be able to unlock a whole new layer of intelligence. To demonstrate the capability of local AI, we decided to build something really special. I'm excited to announce webAI Assistant. While Navigator is focused on solving enterprise problems, Assistant is built for everyone, and it lives natively on your device and allows you to tap into webAI models without any connection to the outside world. With the Assistant, your data remains on your devices. It can run on laptops, phones, and even virtual reality hardware registered to you and your webAI account. This enables incredibly dynamic AI experiences. And what this means is webAI can intelligently scale up and down compute based on the task-specific needs, offering the concierge model experience. Assistant lives in your toolbar and can be accessed at any time. Let's take a look at what this looks like. You'll see that I have 3 folders on my desktop, one named Decentralized AI. This folder could be full of images, graphs, and other content if you wanted to have a conversation with it in your operating system. But I'll go ahead and right-click this folder and click the webAI icon. It brings the folder directly into my chat window on my interface, and now I can ask a question about the folder. I'll start by asking the question, what is a control layer? And you'll see webAI is generating a response, and it will provide me detailed feedback of where it got the information from, providing citations at the bottom.
enabling me to find more information on the initial question I asked. Assistant can interact with your screen, your folders, and apps, all completely local, enabling the privacy and power users desire with no compromises. Let's take a look at how today's announcements come to life with some real-world examples. We'll start with personal health data, something you'd rather not expose to the world. Local models can offer personalized analysis of health data without the data ever needing to leave the device. In this example, I'm going to ask a question around how many steps I took on July 3rd. You can see the model provides detail on steps and references the data points in my folder. I'm going to ask how many calories I burnt on the 15th. We notice here in the response, it provides me a calorie count, but it also understands that I was referencing the month of July, automatically in the system's chat. In the transportation world, trains are producing large data streams, from embedded sensors that measure temperature, system degradation, passenger counts, and much more. Analyzing this data on the fly is not feasible. Using webAI, I can connect to the data stream and ask questions in real time. I'm going to ask a question about a travel log from Seattle to Chicago. You can see here it provides tremendous information from the station it left and the time of day, all the way to temperature. Now I'm going to ask about a different trip, specifically New York to DC. You'll see the model adapts, references a new data point, and provides all the information required in my question.
We're still in the early days of AI, but we're making rapid progress towards building powerful AI applications that afford you the privacy and power you require. Today, we announced 3 critical components of the webAI platform. We started with Navigator, which allows you to easily fine-tune models and connect to local devices, bringing AI directly to where the data is being created. We announced webFrame, our service which allows you to deploy a large model and host it across multiple devices in your network. And finally, the webAI assistant, your personal context-aware assistant who lives on your device and keeps all your interactions private. We're opening up access today, so head over to webai.com to get started now.